Worksheet number 5, confidence interval for the mean. No population standard deviation is given. In fact, you're only given the sample data. Okay, so pause the video so you can read the problem. Okay, let's go. So we are given students are studying, investigating the lace ruffles. Is that how you pronounce it? Okay. So there are 6 bags, and the packaging says the weight should be 28.3 grams. So they wanted to know if that is true, and so they sampled 6 bags, and these are the data right here. And we are supposed to make a 95% confidence interval for the mean. Okay, so let's start. We always start with the assumptions and conditions. Bags were randomly sampled. Okay, so the net weight of each bag is independent. Then we get the 10%, less than 10% condition. And so we say the 6 bags is less than 10% of all bags manufactured. And then we go number 4. Number 4 is a little bit tricky. Okay, nothing in the problem says about the distribution of the population. Okay, it doesn't say normal or unimodal and symmetric here. Okay, so we are just given the data. And so the way we approach this is we are going to make a spreadsheet of the data. We're going to encode that in the calculator and look at the histogram. Okay, so let's go calculator. Okay, I've already encoded the data. Okay, as soon as you finish encoding the data, I want you to make it a habit to get the one variable stat always before you look at the histogram. So you go menu, stat, and then stat calculations, and then do one variable stat. There you go. And so the list is lace and hit OK. Okay, so we want so the mean, this one is 28.78, and the standard deviation is 0.402. Okay, let's copy that one. Okay, so let's look at that, and we want to see the histogram now. So let's look at the graph, and say graph, click here, go lace. Okay, and then let's look at the histograms. So menu, plot type, histogram. Okay, if you notice, the histogram has too many gaps, so we are going to close those gaps. Okay, so we can have a better idea of what the histogram would look like, the histogram distribution would look like. Okay, so we are going to adjust the bin size. See the width of these bars, we are going to adjust it. So we go plot properties, histogram properties, and then bin equal bin. And then if you recall, the standard deviation was 0.4, so we are going to use that standard deviation here instead of 0.1. So we're going to do 0.4 and then just hit enter. Okay, so you cannot see the whole graph. Okay, so we have to zoom out. Menu, Windows zoom, and then let's zoom the data. Okay, you can see the histogram is unimodal and symmetric. Okay, the idea here is look, we're only sampling 6 bags right here. Had this been like had the sample been large, then this would be approximately normal. Take note, I said approximately normal because we are going to be using the T model. T models are approximately normal. Okay, so the histogram of the sample data is unimodal and symmetric. Okay, so let's go write that here. Okay, the 6 bags is a small sample size, but the histogram is unimodal and symmetric. Okay, you are only going to do this because the sample size is small. Had the sample size been large, meaning 40 and above, all you need to write here is the sample size is large enough because it's 40 and above. Okay, and so let's finish this. Okay, with conditions met, we assume T model, see, and perform a one sample T interval. Okay, I'm going to make a part 2 video because this is taking too long.